So the first thing we're going to start with in lecture 7 in the case studies for the design process is we're going to discuss your responses to the last case. Veronica put those together. Just to remind you, for this automotive components testing problem, we had, it was safety testing for this Z100 case, and there was the engineer, Charlie Long, and the question was, should Charlie Long reveal everything? His belief that the testing was inadequate in his recent discovery, that is, he figured out the design flaw, and cost the company a great deal of money, or should he testify that he had been convinced that the testing was adequate? Should he keep it to himself that he now knows that there is something wrong with the design? Here's some student answers from you people. First person said, Charlie should tell everything, but as a middle ground approach. So he should stress that at the time, his team thought the testing was adequate, but he should also explain his process of finding the new problem and how to fix it so the problem can be resolved. This way, hopefully, Charlie can stabilize the damage to himself and his company and the people as much as possible. That's a creative middle solution. Sounds good. Sounds like a smart decision, because the student is saying, just be honest, tell the truth, but give the whole history so that you defend yourself too. Next, yes, I believe Charlie should testify that he did not feel comfortable with the original testing as well as sharing his new discovery. His first obligation is to safety of the public, and if his company is responsible for someone's death, it is his duty to be honest and avoid keeping secrets. Good response. It's exactly what guidelines in engineering ethics would say. Next, Charlie should tell that the initial testing was believed to be adequate, and that once he heard of the issue, he examined the design and figured out how to fix the issue. If he says that he told his supervisors more testing was needed, he would likely lose his position with the company. This is a little bit different response, right? So what this person is saying, hey, watch out for yourself, okay? Don't come out too opposed to the company. In this case, it's pretty nice because it sort of nicely shows where you'll fall on the line between safeguarding the public, like the last response, and being loyal to the company so you don't get yourself fired. Now, what generally happens with this attitude, actually, these attitudes shift over time from what I've seen. So, for instance, when the economy is bad, people are very careful not to be negative towards their company, so they don't lose their job, because they may not be able to find another one easily. But if the economy is real good, they're quick to bring these sorts of issues up. So that's just the reality of what happens. But this person, for me, in terms of the ethical guidelines of the course, the previous answer was a better answer. Next, he should tell his company about the solution to the problem. Good. He should state under oath that they were confident the sensor worked as it left the factory. Okay. But believe that further testing would probably have been a good idea. Okay. So he's saying, come out, tell the truth. Next, Charlie should be honest and explain that he had doubts about the testing. He should not feel required to reveal the design flaw he later discovered. If that is brought up in court, he could argue that it would have been revealed with more testing. See, there's all kinds of different responses here. This revealing the design flaw is what's at the hairy edge of whether you should you do it or not. I mean, in a certain sense, I can see why people would argue, well, why air your dirty laundry, I guess is one way to put it. In another sense, if you reveal it, does it really help safeguard the public? Somebody could argue. So that's quite a difficult one right there. But that last statement's a little problematic, because if it's brought up in court, he can get himself in a sticky situation. He can't just bring it up in court and act as though, well, the problem will be revealed with further testing, and then he would feel like he should bring it up right then. And then he would feel like he was caught, right? So you got to be really careful with this, and sometimes just putting it all on the table is a better decision. Okay, those are all the student responses. Any comments? Okay, we're going to go on and continue with these cases, and in particular, I want to start right here. So Arthur is a chief engineer in a components house. As such, he sits in meetings concerning bidding on contracts. At one such meeting between the top company executives who are interested in getting a major contract and the National Aeronautics and Space Administration, NASA, NASA presents specifications for the components that are to be several orders of magnitude more reliable than the current state of the art. The components are not part of a life support system, yet are critical for the success of several planned experiments. Think something like space shuttle. Arthur does not believe such reliability can be achieved by his company or any other, and he knows the executives feel the same. Nevertheless, the executives indicate an interest to bid on the contract without questioning the specifications. Arthur discusses the issue privately with the executives and recommends that they review the seemingly technical impossibility with NASA and try to amend the contract. The executives say that they intend, if they win the contract, to argue midstream for a change. Okay, so this gets a little problematic then, because they're going to go with a proposal to these people at NASA and say, we're going to solve this problem that you proposed. We're going to make this component this much more reliable. Okay, knowing full well they can't do it, knowing full well they're going to argue midstream for a change. They remind Arthur that if they don't win the contract, several engineers in Arthur's division will have to be laid off. Arthur is well liked by his employees and fears the layoffs would affect some close relationships. So what should Arthur do? What would you do if you were Arthur? Yes.
Try to work with the executives. Because I mean, they make the final decision, and I feel like this happens a lot of times in these sort of situations. But
yeah, I think you're right. I mean, so he says you should try to work with executives in some way, and that these kind of situations you get into a lot of times. The problem is these executives aren't necessarily technical people, right? They may not fully understand that this cannot be done, okay? And they, of course, want money for the company. But what are you going to talk to the executives about? I mean, are you going to you want to try to, talk them in going to NASA beforehand?
maybe sort of give them some perspective by coming up with like some actual data to show them that
It's not possible.
Yeah.
So educate them is what you're saying. Educate the executives so that a good decision is being made. Let me just play the devil's advocate. So let's suppose that the executives say to you, they listen to you and did this beautiful presentation, you did all this work, and they say, okay, so we can't do it. We believe you, but all our competitors are applying for this money. We don't get it. Not only will we lose the engineers, we lose competitive advantage. So what do you do?
Well, by doing that, you'd give them some perspective for like the midstream arguments they'll have to give to NASA in order to get them to reduce those standards.
But the fundamental problem is up front. It's saying you can do something that you cannot do. What really stinks about this case is you're put in a very bad position by the government, by NASA, right? I mean, it would be nice if you could go educate NASA, right? But the problem with doing that is they may take offense. But the other thing is they might say, we know all that. We want to see if there's some great innovation out here that can really make it happen. So let's suppose you do everything you said and you start writing a proposal. You're involved in writing that proposal. Okay. Now, there is where I think you can do something real. Because when these proposals happen, engineers are writing the bulk of the proposal. Okay. And the way you word things we're going to make every effort to do this, or we're going to try to innovate this, without promising definitely that, is probably the best way out in this situation. So that in the end, the proposal is honest, okay? But you are bidding on it anyway. That's likely, from an engineering perspective, to be the right way to go. And the executives, in my experience, the way this is going to go too is they're going to read the executive summary of the proposal, and I mean they're not going to pick through your technical details. They're not going to. So there may be a creative middle solution here too, where you try to weasel through this sort of situation. And in that sense, it's a good case because it shows there's ways out from situations. Yeah.
A lot of the time, especially with research, proposals don't always deliver. In fact, they probably often don't deliver what they're actually applying for.
That's right. You're right. Absolutely right. Research proposals don't. So if you set the tone in the proposals being a research type proposal, you're going to be okay, I think, in the end. I think it will work out. That you're being fully honest, fully ethical in applying for this. Any other comments? Okay, let's go to the next case. Next case is Challenger disaster. Yes?
Just one last thing I thought of. Ask NASA for their documents. Maybe someone actually wrote down an order of magnitude wrong.
Yeah, just verify it with them because maybe they were off by 10 or whatever, 10 times. Yeah, could be. You might want to check with them. Okay, Challenger disaster, which is an amazing case. So this was, you remember the space shuttle program's over now. It was a delta wing craft with a huge payload bay. Had 3 main engines fueled by several million pounds of liquid hydrogen. So what you had is, if you remember, you had these 2 big tubes along the side, right? Those were each an engine. And then there was one that was on board the actual delta wing craft, okay? And that point out this way, they like to have that triple force going down for stabilization, be able to point this thing, okay? Now, 3 million, several million pounds of liquid hydrogen in those big tubes, okay? So it's got a ton of fuel. That thing needs to burn off to push the thing, get out into outer space. So these are the immense external divided fuel tanks. During liftoff, the main engines fire for 8.5 minutes thrust for the first 8.5 minutes for the first 2 minutes, provided by 2 booster rockets. The booster rockets are fueled by solid fuel. I'm not sure why it's a solid fuel, but apparently they can pack more energy in the fuel via this method. The casing of the booster rocket is about 150 feet long and 12 feet in diameter. This thing's massive, okay, holding all this solid rocket fuel. I mean, 12 feet in diameter. I mean, 150 feet long. It's probably, to give you an idea, it's probably 60 feet from that corner to that corner, okay, so it's double that length. So what happened with this is NASA plus companies, for instance, Rockwell International, they did the orbiter and the main rocket, and Morton Thiokol did the booster rockets. So we're going to be focusing on Morton Thiokol because that's where the problem originated. So after lots of embarrassing delays, flight set for Tuesday morning, January 28, 1986. This is one of those kind of events where people my generation is like, where were you when this happened? Everybody knows where they were when this happened. Okay. So what happened before? Well, there's A.J. McDonald of Morton Thiokol worried about predicted freezing temperatures since he knew of problems with fuel joints on previous cold weather launch. Okay. He arranged a telecon. A. Thompson, and this is Roger Beaujolais, I've heard, he came to OSU and gave a talk years ago. These are SEAL experts at Morton Thiokol. Explained how booster rocket walls bulge and combustion gases can blow past one or both of the O-rings that make up field joints. So the way this booster is designed, it's like you got a cylinder and it's in pieces. It might be like this much of a cylinder, and then the next one stacked on top of it, stacked on top of it. You get 120 feet long, 12 feet diameter, and in between those, you have O-rings that are like some kind of rubber, okay, that makes sure there's no leaking, okay? That's where the problem will arise with the O-rings. So O-rings actually char from the heat, fire, etc., and erode as seen on many previous flights. So they've been monitoring this. NASA, this was a growing problem. They knew there was an issue, okay? In particular, in cold weather, the problem's aggravated because the rings and putty packing are less pliable. So just think, rubber gets cold, it gets hard, and it can kind of crack and fail. That was going on in cold weather. In fact, the past flights show that below 65 degrees, remember they're launching in Florida, right? Launches always resulted in failure incidents with O-rings. Wow! I mean, they knew these things were failing. They might be leaking a little bit, okay? Very serious issue. Keeps happening, especially when it's cold. Okay, your book has a plot on this. It shows this. This very clearly was a problem. So engineering managers Bob Lund and Jay Kilminster agreed there was a problem with safety. During a recess in Telecon, Senior VP Jerry Mason turned to Lund and told him, and this is where things got problematic, to take off your engineering hat, put on your management hat. Okay? So the tone there was, you have to prove to us that there will be a problem if we launch. The problem is they're showing all this past data, they're explaining all the previous incidents, and they're still going to take off because the engineers can't prove to them there definitely will be a problem. NASA is trying to avoid public embarrassment, is always delaying the flight of the space shuttle. Okay? So the problem was that the temperature, they took off in the morning, okay? A temperature was only 36 degrees, all right? And they were having problems anything below 65 degrees. Smoke came from a fuel joint, flame, hydrogen caught on fire, tank broke loose, smashed into the wing. I could have gotten a YouTube video. It's a sad thing to see this thing blow up. This thing is a fireball by 76 seconds. Okay. So, out of the people that died, you've already seen one of them. See Jay Resnick, that's Judith Resnick. She's an electrical engineer and an astronaut. So the question is this is a complete screw up. Okay, NASA lost huge problems of reputation, not to mention lives, expensive craft, etc. I mean, it was a huge problem. The question is, when they look into it, what could they have done differently? So, could there have been a clearer presentation of the problem, the temperature influence on O-ring failure? Could they have made more forceful arguments? You really have to watch for these growing problems. And don't take off your engineer's hat. Roger Beaudelet, when I heard him give talk, he had a pretty good audience, and a woman up front asked him, why didn't you go public? Why didn't you blow the whistle? And he said, I was so busy fighting inside, I had no time to go outside to the newspapers or whatever, number one. And number two, he said, I don't think it would have mattered. I'm like, one person, one engineer, lowly engineer complaining about NASA administration. He felt his time was most effective fighting the battle inside. Although he did admit, after he said that, he goes, well, I'm not positive I shouldn't have done that. And he said, maybe it could have made a difference. Okay? Go read this case in the book, it's shocking that, you're going to side with the engineers. If you look at the data on the failures from before, it's just amazing that they allowed this thing to take off. Okay, what happened? There's lots of evaluations, special commissions, etc., put together to evaluate what happened. And one aerospace engineer said, the arrogance that prompts higher level decision makers to pretend that factors other than engineering judgment should influence flight safety decisions, and more important, the arrogance that rationalizes overruling engineering judgment of engineers close to the problem by those whose expertise is naive and superficial by comparison. Wow, this person's pissed. You know, I'm sure he cleaned it up for his official statement. I mean, but you know, this kind of stuff happens. When I was in the engineering industry, I had a strong sense of being like a peon, you know? It was the business people that are running this organization. You have no power. Go design your techie stuff and we're going to make money off of it kind of attitude, you know? And so, you know, there is a real problem with engineering in a sense, but part of it comes from engineers not sort of stepping up to the plate, trying to lead, complain, etc. And I hope you can do that in your career without ruining your career, too. Okay, next. Next is an interesting case where there's a flaw in the Intel Pentium chip. Used to be, every time Intel released a new Pentium chip, everybody was all excited because they're going to plug all these into the PCs and everybody's going to be able to go faster. So they come out with their latest and greatest. In late '94, though, the media started reporting a flaw in Intel's Pentium microprocessor. And it was a chip used in 80% of all personal computers of the world. I mean, this is like all over the place. The flaws in the integrated circuits of the microprocessors are not uncommon. This happens all the time and cannot be detected. But this flaw was different. It caused incorrect answer when performing double precision arithmetic. I mean, can you imagine that? How often do you use double precision arithmetic? A lot as an engineer. I mean, you're using it all the time, right? And it was easily detectable. The Intel response when this came out, and there was some very reputable people showing exactly what the errors were in the computations. They acknowledged the error, said, yes, we do have a problem, but they said the defect was insignificant, and the vast majority of users would never even notice it. Why did they do that? That first statement. The reason they did it is it was only people like us that really ran into the problem. If you're doing standard word processing, blah, 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 no problem. So Intel looks at the percentage of people doing what, and they say not that many, not that big of a percentage is doing those kind of computations that will cause the error, so be it. Then they said, we're going to replace the chip for users who could demonstrate that they needed an unflawed version. In other words, you prove it to us, we'll give you a new chip. I mean, we're talking about a chip, you know. It's expensive, but they took this attitude, so like engineers, so forth, could start, applying to them, get a chip replacement for the computer. Users, however, were not happy. Why? Because most users don't know whether they go into double precision arithmetic, right? I mean, you just don't know that. Do I know when I'm messing on my computer when I go to double precision? No. I know that I'm in double precision when I'm using MATLAB and Simulink. Okay, I know that. But am I sure that when I do PowerPoint, I'm not using double precision? I just don't know. So users in general said, what do you mean you're only going to give it to them? Well, we deserve to have products working. We paid for this product. Okay? So IBM, the major Pentium user at the time, canceled the sales of all computers using the chip. Okay? Remember, IBM's separate from Intel. So they got a lot of negative press, Intel did, an outcry from Pentium users. Intel agreed to replace the faulty microprocessor with an unflawed version for any customer who asked to have it replaced. Okay. So they cleaned up their act. Long before the news of the flaw surfaced, Intel was aware of the problem and corrected it on subsequent versions. So actually, Intel had a bunch of these things manufactured, and they knew it wasn't going to work, and they shipped them all anyway. All right? Really a bad decision. Of course, very expensive decision, just throw them all in the trash, too. So they were selling a flawed chip, came out later, and they knew it. So the new Intel policy became flawed chips should be replaced on request regardless of how insignificant the flaw is. Okay, so they're getting better. Now the question, this is a public relations problem, but it's got ethical problems because they were selling a flawed chip. It's a hardware device. It is not something, well, there was no social experimentation involved. They knew it was bad when they were selling it, right? It was social experimentation only in the sense that when they put it out there, everybody complained, they found problems and complained so much they had to fix the problem. Okay? So the questions that Flederman asked, the guy that came up with the case, is should flaws always be revealed to customers? Wow, that's a tough one. I mean, you and I know there is nothing on this earth that's perfect. That's my wife. There's nothing on this earth that's perfect, and therefore, it's like, you create this technology, you pour your heart into it, your team pours their heart into it, you know there's a flaw because you know your technology so well. Do you have to reveal that to your customer? That is a tough one. Okay? It depends on many things when we're talking about this class, especially safety and health. Okay? Is it an ethics problem only if safety is involved? See, a lot of people would look at this case and say, there's no ethical issue here. There's no safety problem. The the Intel processor, Pentium, there's no safety issues whatsoever associated with it. It's just like, what am I going to do? Hurt somebody when they're doing word processing by crashing, something like that. I think you got to be careful with that because there's a lot of that Intel chip was being put in a lot of different computers, and I suspect there's some safety issues sometimes. What if they added a label? This product may contain unexpected flaws and might not operate correctly under all conditions. Now, they do these kind of things with some technologies and products, right? You read it and you're like, it's depressing. What do you mean you're selling me this? I mean, what do you mean it may fail? It may not work all the time? Yet, it's funny, we see those labels often enough these days, I think, to ignore them, right? We ignore them. And yet, the lawyers love a statement like this. Because you come back, they'll say, oh, we told you it's right here in black and white. So does that really solve the ethical problems is the question. Okay? Comments? So, next, how can an engineer be sure that there are no defects in a product? You can't know, is the reality, right? You test, you try to figure it out, but you're never certain. You're never certain your design is correct. Period. I don't care what design it is, I don't care what circuit it is, computer system, control system, communication, in electrical engineering, I don't care about all of engineering. I mean, there's always problems, there's always defects. The question is how significant they are and what the probability is you're going to cause a problem with safety health. Okay? If it's impossible to eliminate all defects in a product, what level of defects is acceptable? This is a very hard question. It's sort of, because it's also correlated with the issue of competence. The better and better of an engineer you are, the less and less defects there are, the more and more safe your product is, the less and less it will adversely affect the environment. That's why there's this intimate coupling between professionalism, that is competence and good behavior, and engineering ethics itself, okay? So it does depend on the type of product. I mean, there's certain products that have absolutely no safety implications, but at the same time, there's sort of this honesty in putting out a product that works, right? If you're gonna sell something, you're making a transaction, you're giving a product, they're giving you money, okay? And it should be an honest exchange, right, on both sides, in the sense that you're going to deliver what you say you're going to deliver. Okay. Now, to uphold that honesty on part of the deliverer, we use warranties, right? We say if there's a problem with the product, return it to me, I'll fix it, blah, blah, blah. Okay, next, an NSPE case. Engineer A, an electrical engineer, worked for Dicers, a company that purchased wafers for microprocessor chips from another company, then reprocessed, packaged, and resold them. All right. Engineer A was assigned the task of testing the wafers. After a while, Engineer A was instructed by his supervisor to alter the testing process to which both parties had contractually agreed. The testing process was altered over engineer A's objections in such a manner that the quality of the purchased wafers was made to seem lower, when in reality there was not a reduction in the quality. This lowered the price paid by dicers to the other company. Engineer A objected to this practice and refused to go along, and as a consequence, he's fired. Okay? So the question is first question, there's a number of questions. Let's start with the one I have there in red. Did engineer A do the right thing? You say yes. Anybody? No. I mean, this is a tough situation because engineer A is fighting the management, right? I mean, this is quite unethical. I mean, it's against the agreement with the company. They're going to, of course, engineer A's company has a vested interest in doing something like this because they're going to make more money because they're not going to be able to, they're not going to pay as much for the product. Okay, but so the question is in this case is, when do you fight and when do you walk? Right? I mean, it's not clear from the statement of the case. This comes right off their website, so I didn't change the statement. How much engineer A fought? I mean, in a certain sense, this he said so he should not quit. You should get in there and what could he do? Let's say he doesn't quit. What could he do? What more could he do that's not stated right here? Yes?
Did he find out if the changes to the process was agreed upon by both companies so that they weren't doing additional testing to save money on the product? That's why the product was cheaper?
Well, I think it's pretty much saying that the process for testing was agreed upon, and they're changing the process unilaterally. So this company is going against the agreement with the other company. Yes?
I think he did the right thing by leaving because since this was like sort of an under-the-table change, that just makes him not legally liable for any issues that may arise.
Well, you're right. From this case, it doesn't seem that he is liable because he doesn't seem to be the one redesigning the test, enabling this bad behavior.
But he could be.
But what could he do without quitting? Yes?
He could go above the supervisor's head to kind of bring it to higher management and say, yeah, we're trying to save money, but at the same time, this could come back to bite us in a lawsuit if we get caught.
Good option. Go over the boss's head. That's actually considered whistleblowing within an organization. Now, it can ruin your career, okay, but it would be the right, honest thing to do, right? What else could this person do? Who else could he go to? Let's say he's done all the fighting he can. They're clearly not going to listen. You go over the boss's head, or
Go to the supplier.
go to the company. Go to the other company and tell them what they're doing.
He probably wants to know why their property's going down.
Yep. I mean, if you go to the other company, and I mean, look, would it be okay to go to the other company and do it privately? In other words, so your company wouldn't find out you did it. Just let them somehow discover that they're not being treated fairly. That way you protect your job and fix the problem. Is that okay ethically or not? Do it privately. No? I'm seeing a number of no's. Why not?
Obligation to your own company.
I'm sorry, what?
You have an obligation to your own company.
You have an obligation to your own company, so you shouldn't be going outside the company?
Yes.
Yeah, but he quit.
He was fired.
Yes, true. I'm sorry, he was fired. So, in a certain sense, what you're saying is he's loyal, that's good, he should not be disloyal by going to the other company.
Once he's fired, he has no obligations to that company anymore.
Maybe he should go to the other company then?
Yes.
Oh, interesting. That's like a student case we had in here a number of years ago. Is the student was a co-op. I'm getting ahead, but whatever. He was asked to dump hazardous waste down the drain. Said no. They fired him. What did he do? He went to EPA. The EPA came and got the company. Okay. So, okay. Anything else? Okay. Here's another case. Engineer A is an electrical engineer working in quality control at a computer chip plant. Engineer A's staff generally identifies defects in manufactured chips at a rate of 1 in 150. The general industry practice is for defective chips to be repaired or destroyed. Engineer B, Engineer A's supervisor, recently announced that defective chips are to be destroyed because it's more expensive to repair a defective chip than it is to make a new chip. Engineer A proceeds on the basis of Engineer B's instructions. A few months later, Engineer B informs Engineer A that Engineer A's quality control staff is rejecting tuning chips, which is having an effect on the overall plant output. And ultimately, company profitability. Engineer B advises Engineer A's staff to allow higher percentage of chips to pass through quality control. So let's start making defects. He clearly knows he's going to start making defects. Engineer B notes that in the end, these issues can be best handled under the company's warranty policy, under which the company agrees to replace defective chips based on customer complaints. Engineer A has concerns as to whether this approach is in the best interest of the company or its clients. How do you side with? You got Engineer A in a tough position here. Do I start releasing a higher percentage of defective chips? And I know they're defective. I know, in these situations, they know the percentages of defective chips. They know exactly what they're doing. They know exactly then that they're selling defective product to a customer. So in that relationship between buyer and seller, they're not upholding that sort of contract. They're selling, crappy stuff, and person's not getting the deal. And you could say, yeah, but they get the warranty. So what's wrong with that? Reputation. That's a huge issue. You don't want your company to have a bad reputation of creating bad product. Why? Why do you care about reputation? You lose customers. What else? You lose employees. You can't hire employees. I mean, people want to work for companies that are perceived as good companies, right? The best, highest quality products, etc. You want to work for those companies. So you lose good people. Generally you lose customers because they don't respect you anymore. It's a huge problem. So, having these kind of concerns, this is a big issue. What can this engineer do about it, though? What can Engineer A? An Engineer A, let's say, is going to slide put himself on the side of making higher, more reliable products. Okay. How can he go about that within the company? Because the problem is, engineers typically don't run companies like this. Yes.
Maybe do some process management to figure out where all these defects are coming from.
So put on his engineer's hat, get confident, try to figure out where the defects are coming from, and reduce the number of defects that way back to the original level. That could very well be, as long as he's got the time. Not assigned some other tasks. Okay. You may have to go over the boss's head, like we mentioned before. You probably would not go to the Columbus Post Dispatch over an issue like this. This kind of thing is an internal issue, fundamentally. Okay. Next. Engineer A is a graduating. Oh, I love this case. Engineer A is a graduating. Whoops, I bumped it. Engineer A is a graduating senior with excellent credentials from Ohio State University. Engineer A has had a series of job interviews with engineering companies from around the U.S. Following interviews with several industrial companies, Engineer A decides to accept an offer with ABC Incorporated, located in his hometown of Akron, Ohio, or whatever, and plans to notify ABC the following week. In the interim period, Engineer A receives a call from Engineer B, an executive with XYZ Incorporated, a potential employer with whom Engineer A had interviewed. On behalf of XYZ, Engineer B offers Engineer A a position with XYZ and invites Engineer A at XYZ's expense to visit XYZ's headquarters in Mountainville, a city located near a resort area following Engineer A's graduation. Engineer A had earlier decided that he would not accept a position at XYZ if offered a position by ABC because Engineer A wanted to be close to family and friends in Townville, and also because ABC provided better long-term professional opportunities. However, after receiving the call from XYZ, Engineer A decides to accept the invitation to visit XYZ's headquarters and combine the trip with a post-graduation vacation, believing that the visit to XYZ will broaden Engineer A's knowledge of the employment market, as well as future professional opportunities with XYZ. A week after the trip, Engineer A calls ABC to inform the company that he will accept the position at ABC. So, this is one of you, let's say, as an ethical. This is a very set situation here. Is it ethical to go there, XYZ? I'm seeing a thumbs up from somebody out here in the middle. Go take that vacation, baby. Anybody else? Yes?
He can go out there. He's giving XYZ the opportunity to try to steal him from ABC. They could change his mind. It's entirely possible. He made some of the reasons that he wanted to go to ABC was because.
Yeah, there was a professional opportunities reason, right? And be near family and friends. Conceivable. Yes.
I would say because he already interviewed with them before the invitation was done. I mean, obviously there was interest there, and like the vacation side of it, it seemed like he was already planning to go there anyway for the vacation, so that was coincidental.
No, I don't think he was planning on going there for vacation. I don't think that's.
He's going to go somewhere.
Yeah.
He might have vacationed somewhere, but maybe not here. I mean, by what it said. I'm just saying, by my interpretation. I would say. Anybody else? Okay, so, yes.
It's saying, like, we're assuming that he's guaranteed still going to go to ABC after he takes the test.
It sure implies that by the way this is written. It is implying here that he is definitely planning to go work for ABC for two main reasons: near family, friends, long-term professional opportunities. And it ends up being the case that he does go there after talking to XYZ. He already interviewed with XYZ. He seems to know what's going on there and rejected that.
I think that, I guess that might be a topic we have to deal with, like, internally, like,
Yeah, it's a very, see, you're right, this is a very personal issue. There's nobody at risk here in terms of safety, or health, environment, none of that going on. This is a very different case. This is a case, a lot of ways I'd call it, sort of personal ethical decision making. And I would say, if you explain, let's say you put yourself in this situation and you told a friend of yours about this. How many friends would you think would say to you, come on, that's not ethical? And how many would say, so what? But maybe you don't care what other people think, granted. But most would say what? So what? How many people would say, so what here? Raise your hand. How many people say, I think there's a problem here? Interesting. See, there's controversy on the case. One of the people that rose their hand. Second, want to comment? Yes.
Well, I was just going to say, like, I don't really like how the questions got. It's specified on he's recently graduating and going to one of these companies. If he was working for a company and interested in transitioning to another company, I don't know why, but I feel like that would be a different case because
That would be a very.
I just think a lot of people here, for example, who would be graduating and haven't gotten like a full-time job, for example, in engineering, would be interested in going to XYZ to see what they have to offer. Because I don't think anyone's going to be like, oh yeah, I'm going to work for this company. Absolutely. That just seems like something that I don't think a lot of recent graduates would relate to, which I think is kind of odd. Because they're saying that he's going to ABC for sure.
Yeah, and it's worded carefully.
I guess if that is true, that he, that's just his decision, then yeah, it would be unethical. But at the same time, I just think it's kind of an odd situation versus being at a company and
Right.
transitioning to another company.
Related things happen, though, to our undergraduates all the time. How many people here? Yeah, we got a few minutes. How many people here? Let's say you got a very simple situation. You've interviewed with some companies. All right, I don't know, X company. You interview with this company, and you're like, this is a great company. You call them up, accept. You write a letter, put it in writing, accept, and then another company shows up. Okay? They interview you and give you more money, and it just looks better. And so you want to dump the previous company. How many? Show of hands. How many people dump the previous company? How many people do not? It's tough. That's a tough case, and that happens. You guys, all of you people are facing that issue. That's not what this is. No, I changed the subject. No, I very clearly say change the subject. I changed the subject partly because of what he was saying. I mean, this case is the more common case for you people. And that is a very difficult case. I'll warn you, you'll get into it. Okay? Alrighty, let's go to an attendance question. In the case where the electrical engineer is working in the quality control of the computer chip plant, and he's trying to decide about lowering the reliability or the percentage of failed chips, or allowing it to go up. What is engineers A's obligations? Yes. I couldn't hear you. I'm sorry. Oh, yes. This is a situation whether he was to allow or not a higher percentage of defective computer chips come off the line, and he was demanded to do so by his boss. Yeah.
There's a question about when is the next one due? According to your website, it's assigned next week and then due the week Chapter.
Yeah.
But there are other things like farmers that are saying it's due next Monday.
Well, why don't I talk to I'll talk to Veronica about that. The website's crap.